The imaginary unit I, complex numbers just include I. You guys have already worked with the I before. Again, I told you a lot of this is going to be review. It refers to the square root of -1. The square root of -1 is equal to I. And then I squared is going to equal the square root of -1 squared, or just -1. So a complex number, imaginaries just mean they have I. Complex is like what we just kind of worked with, where it has a real number and an imaginary number. So it would look like 2 plus 2i, or 2 plus square root of 2i, or something like that. Okay. So it's adding real numbers to real multiples. So for example, a plus bi, or something like 5 plus 3i. Oh, you telling him to go?
Oh, that's right. That B, C, or D, I?
So two complex numbers, a plus bi and c plus di, written in standard form, are equal to each other. So we're going to write them equal to each other. If and only if a is equal to c and b is equal to d. Operations with complex numbers. To add or subtract two complex numbers, you add or subtract the real and imaginary. Sorry. Real and imaginary parts of the number separately. Adding and subtracting are really simple. So for two complex numbers, a plus bi and c plus di, written in standard form, the sum and difference are defined as follows. If we had a plus bi plus c plus di, the way that we would put it together is you add the reals, add the imaginaries. The difference is going to look just the same. If I had a plus bi, and I'm going to subtract c plus di, then I'm going to subtract a and c and subtract b and d.
Only works if A and C are the same value as C and D.
No. So they can only be equal. These two can only be set equal if a and c are equal and b and d are equal. There's no other way. That's fast.
See? Yes, I'll wash my hands.
There has to be like A and C.
Freaking
would
red.
both- A and C would both have to be
I'll
equal,
do
and B would do both have to be equal.
Yeah, to be able to like set it equal, so like 2 plus 3i can only be equal to 2 plus 3i. You can add anything and subtract anything, but to be able to set them equal, you have to have the same value.
Okay, so percent of difference, that is not the case.
Correct.
Oh, good.
Yeah. I'm not good. This is it. This is the end of the paper.
Can I get back up on paper and just-
No.
No, sir.
Well, how much do you need? I'll give it to you after we're done.
Words.
I'll give it to you after we're done. All right. So when we're adding, we're gonna add the real parts. So like terms, this is just like having an X on here. 4 plus 1 is. And then you're gonna add, again, the I terms. 7 plus -6. Or just 5 plus I. Treat the I just like an X. One more time. Treat the I just like an X. So if you're adding part B, what's 1 plus 3? 4. What happens to your 2I minus 2I?
It goes away.
No, no.
You just gotta enjoy it while it's.
So on C and D, the only difference in subtraction, we've talked about this already this year, is if the subtract is outside, make sure you distribute it throughout. So we're just gonna rewrite this. 3I is fine. I'm gonna distribute my negative. What's that gonna change it to? +2 and minus 3I. Distribute this negative. That's gonna change it to -2 and minus 5I. Typically, and it does not matter, guys, they do the real numbers first, so not the I's first. So that's where I will always start. But if you give it opposite, it's still the same answer. So what happens to your 2's? What happens to these 3 I's? What am I left with? That's it. So it's regular addition. It's nothing crazy. So what am I going to change D to? The 3 plus 2I is good. We have a plus, so we can just keep writing +4 minus I. But then everything behind the minus needs to change. So -7 minus I. Add your like terms. What's 3 plus 4? Minus 7. What's 2 minus 1? Minus 1. So your answer is 0. Again, nothing complicated, it's the same thing. Just dealing with the same thing.
Do I need to get that other little part later?
I will get it to you in a minute.
Long, sweet, long.
Just distribute your negatives and then add your like terms. So 2 minus 2 is 0. 3's cancel out and you're only left with -5.
Oh, so you're not multiplying.
No, not multiplying yet.
So it's just one times after. You should be careful.
Yep. All right, now we're gonna multiply.
Yeah.
So the first one is super easy. It's just a regular distribution. So multiply 4 by -2 and 3I. What do we get?
And then plus 12,
That's it. So just distribute your 4. All right. I want to work with C for a minute and then I'll go back to B and D. So look at C. What happens when I have it like this? Double distribute, right? What's 3 times 3? 3 times -2I. 2I times 3. Mhm. And then 2I times -2I. 4 to the second. Yep. Remember what I told you? That I is equal to the square root of -1. So I squared would be the square of the square root of -1, which just means -1. So what I always say is that I squared is a sign changer. That way I don't have to do any work. So I squared is a sign changer. So when we look at this, what happens to our regular I terms? I have a -6 and a +6, they cancel. I have 9. What did I tell you about I squared?
Changes.
So it was a -4, it's gonna change to +4. It's the same thing as saying -4 times -1, which will be a +4. 9 + 4 is 13. That's it. So if you can just remember I squared is a sign changer, you don't have to do the work of multiplying it by
So
-1.
you, like, no I at all.
Nope, because it canceled out and I squared cancels out by I. All right, look at your next one. Go back to B, 2 times 4. 2 times 3i. -I times 4. -I times 3i. -3i squared. Remember that I squared is a sign changer, so I'm just gonna rewrite it so you guys can see it. It'll turn into +3. Add your real numbers together. So 8 + 3, 11. Add your imaginary numbers. 6i minus 4i. That's it. What does square mean? Multiply by itself. We're gonna do the same thing we did in the last 3. Distribute 3 times 3. 3 times 2i. 2i times 3. 2i times 2i. What do we say about I squared? It's a sign changer. So we have 9 plus 6i plus 6i. Sign change it to -4. If you can do all this at one time, then please do it all at one time. It's fine. 9 minus 4, 5. 6i plus 6i, 12i. Complex conjugates, sorry, are the same factors but with opposite signs. And I'll explain this in just a second with an example. If we have 6 minus 2i, the conjugate is 6 plus 2i. So it's just like letter C up here. We're not doing anything different. We're just learning what it's called. Multiply each number by its complex conjugate. So we're going to multiply 1 plus I times what? 1 minus I. What happened up here when we had a plus and a minus? It just cancels the middle out, right? So to do a little cheater method, you can just multiply the front and the back because the middles are going to cancel out. Okay, so I'm going to show you all the way and then I'll show you what I'm talking about. Okay, so 1 times 1 is 1. 1 times -I is -I. I times 1 is I. And I times -I is -I squared. Every single time your middles will cancel out. So there's no point in multiplying your middles in there. It just takes time. Can you do it? Sure. I'm gonna show you how in just a minute. So when we finish, remember I squared is a sign changer. What's the number with us, I squared? So instead of a -1, it'll be +1, which gives us 2. Here's what I'm talking about. All we have to do is multiply our first and our last, because your middles are going to cancel out. So 1 times 1 is 1. I times I squared, or sorry, I times negative I is negative I squared, which turns into 1 plus 1. So if you're multiplying conjugates, they're opposite signs, you don't have to multiply the middle. Can you? Yes, just takes more time. So it's up to you, whatever you want to do. So look at your next one. We're going to cheat on this one. What's your conjugate? 4 plus 3i. I'm lazy, so I'm just going to multiply the first, and I'm going to multiply the last. So what are your first? Your last, negative 3i times 3i. I squared does what? And 16 plus 9 is? That's it. No point in even multiplying the middles because they're going to cancel out. All right. I think this part is probably the hardest in the notes. Everything else pretty simple. So just like square roots, you guys should know how to rationalize square roots. If you don't, we'll do it. I think you guys told me that the other day. But on this, we can't have i's in the denominator. So the reason that, or what we need to do is get rid of them. And what we're going to do is the conjugate. So remember, if we had something like 4 over the square root of 2, to get rid of that square root of 2, you multiply by itself. Does everybody understand that? So I don't know if you remember that, but that's what happens. So then you get a whole number 2 in the bottom, and on the top, you would have 4 square root of 2. We're going to do the same thing. We want a whole number down here. The only way to get a whole number is if we multiply by the conjugate. Okay, so we're going to multiply this by 4 plus 2i. Just like our square roots, I'll make it a little bit bigger for you guys. Just like our square roots, 2 over 2 is 1, or square root of 2 over square root of 2 is 1. So we have to put the same thing over itself. So technically, we're multiplying by 1, which does nothing. It's going to change the way it looks, but it doesn't change the problem. On the bottom, when we multiply that conjugates, what do we need to multiply? Louder. First and last. So first are, last are negative 4i squared. We already learned at the top of the page how to multiply the top. You're gonna have to do all of them because they're not conjugates. 2 times 4. 2 times 2i. 3i times 4. 3i times 2i. 6i squared. And now it's just a matter of cleaning it up. Okay. On the top, if you guys want to do it all at one time, what is I squared? The sign changer, so I can change this just to -6. On the bottom, this is going to change to +4. And then we can do it all together. What's 8 minus 6? 4 plus 12. On the bottom, 16 plus 4 is 20. The very last thing that you need to do is see if you can simplify it. Look at all 3 of those numbers. I talked about triangle of numbers. If you had me, I've talked about triangle of numbers. Are they all divisible by the same number? All by 2. So 2 is going to turn into 1. 2 divided by 2 is 1. 16 divided by 2 is 8. And 20 divided by 2 is. This is your final answer. Right. Same thing on the next one. How do I get this I out of the bottom? What's its conjugate? 2 plus I. What I do to the top, I have to do the bottom. What I do the bottom, I have to do the top. So we can cheat on the bottom and only do the first and the last because they're conjugates. So 2 times 2 and -I times I. negative I
So it
squared,
always takes one at the bottom.
always, always at the bottom. On the top, 2 times 2, 2 times I times 2, I times I. What is I squared? It's just a sign changer. So this is 1 I squared, so it's going to change to -1. This is -1 I squared, so it's going to change to +1. On the top, 4 minus 1, 2 plus 2. On the bottom, look at your triangle of numbers. Will not reduce. That is it. Any questions? Pretty simple, not too bad. All things you've done before. Complex solutions of quadratic equations. If I get something like this, it's just asking me, how do I simplify it? You have already told me this, so I know you know how. How do we simplify this? How do we rewrite it? With the I, right? So I'm gonna write it all the way out so you guys can see it. It's the same thing as 3 times -1. You can split that up into the square root of 3 times the square root of -1. The square root of -1 is I. And we typically write the I in front. I think there are parts of this, I think this book, this book or calculus kind of writes it in the I in the back. So if you see this, you may see I in the back, but that won't stretch across. Don't freak out. Don't freak out. Sometimes they just write it in the back. You probably will. Nah. All right. Principal square root of a negative number. If A is a positive real number, the principal square root of negative A is defined as the square root of negative A. And then how do you fix it? Sorry. As I square root A. So it's the same thing that you already knew. We already talked about up there. All right. Couple more examples and we're done. Simplify each of the following. You sure did. All right. When I multiply them together, square root of 3, -3 times -12 gives you what? Okay, so we got to be careful about this. So it gives you the square root of 36. But when I multiply these, I want to look at this one more time. How do I fix these? Because I can't really do that. How do I fix these? Take out the I, right? You're all right. What did I leave off of this one? The I's. So the I's on the outside are now what when I multiply them together? Everybody see that? So we can't just multiply those together. We got to pull those out before. So we don't want to do it this way. We want to pull out the I's to begin with. What is I squared? Let's change the sign. So it's going to be a negative. What's the square root of 36? 6. That's your answer. So these are a little bit different than what you see. B is literally just simplifying and putting that together. So how do I fix the negatives? Okay, so I square root 48 minus I square root 27. I'm going to come over here and I'm going to simplify these because we're not done. What are your factors of 48? Give me some numbers that multiply to get 48.
8 and 6.
8 and 6. 6 is 3 and 2. 8 is 3 twos. When we're doing square roots, we're looking for pairs. So we have 2 pairs of 2 or 4. What I didn't circle goes under the square root. So I'm gonna go over that one more time. Factor, I do this in math 1, so don't tell me you cannot get this. I don't even want to hear it. You can. So the way we want to simplify this and rewrite our square roots, completely prime factorize. So you said 48 was 6 times 8. 6 is 3 times 2. 8 is 2 times 4. 2 times 2. Very good. We're going to circle our pairs. There are 2 sets of 2s. What's 2 times 2? What's the square root of 4? 2. Square root of 4 is 2. 2 times 2 is 4. So I just say 2 2's come to the outside. That's 4. What did I leave? A 3. Okay, so this is going to change into I times 4 square root of 3, or 4I square root of 3. What about 27? What are your factors of 27? So 3, 9 is 3 and 3. What are my pairs? So I'm taking 1 3 to the outside, and I didn't circle one on the inside. So we're going to change I square root of 27 to 3I square root of 3. What do you notice now? So if I just had 4 square root of 3 minus 3 square root of 3, what would I get? 4 square roots of 3 minus 3 square root of 3. 4 apples minus 3 apples is? So what am I going to have? Square root 3. This one is going to be I square root 3. So 2x minus 3x, 4x minus 3x, anything like that is going to be the same. Same thing. So prime factorize 6 and 8. 6 is 3 times 2. 8 is 4 times 2. 4 is 2 and 2 and 2. 8 is always 3 2s. And then you circle your pairs because we're doing square roots. If we were doing cube roots, you would circle 3s. And then I had 2 come out. So 2 2s is 4. I didn't circle a 3, so it goes under there. This is, again, this is math 1. I'll teach you in math 1.
And the end of math one, we were on.
Miss Rose didn't teach it. Miss Jones, you the only math 1 teacher teaching that.
I'm actually not.
Uh,
I'm not.
We are eighth graders in math.
A lot. Y'all still are in page math, but I'm gonna get that, but at the same time.
I have one question then, so I forgot half of the material.
Lord have mercy.
Is it more big than her? No, and I got spiked in the head twice for volleyball. I got like half of my material.
All right.
She did more. I
Guys.
did more.
Guys. Hush. Multiply the front 2. Positive 1. Negative 1 times the square root of negative 3. Don't make it complicated. Negative 1 square root negative 3. Square root of negative 3 times negative 1. Negative 1 square root negative 3. Square root of negative 3 times the square root of negative 3. What happens to your square roots? So we're just left with negative 3, right? Let's clean it up as is, and then we'll deal with that negative 3 under the square root. 1 minus 3. Negative 1 minus 1. And we leave that negative square root of 3, or square root of negative 3. How do I fix this? This square root of negative, yep. So negative 2 minus 2, pull out the I, square root of 3. That's it. So complex solutions of a quadratic equation on this. Guys, you can complete the square on these. So if you don't like quadratic formula, I think I'm gonna show you both ways actually. So if you don't like completing the square, then you can use quadratic formula. If you don't like quadratic formula, complete the square. Do you guys remember what quadratic formula is?
That's a wrong equation. X equals negative b plus or minus the square root of
Square minus 4AC.
four AC all over two A. Bang.
Very good. Ask Ms. Hoover to sing for you.
Oh, dude, Miss Gordon sung us a song.
Ms. Hoover will sing you a song.
Yeah, it was Miss Hoover's song that Miss Gordon sung us.
There's two
last
of them.
semester.
There's two of them. Oh, then there's three of them.
Oh, God. no,
Sing
no.
that
Oh,
for
yeah,
me.
Miss Rose shows that. 5 years ago.
All right.
Miss Rose is across the hall. You
Oh,
would,
that
she
Miss
would
Rose.
love you.
Oh, I have.
You had her.
Yeah, I have. Well,
Here we go.
half is-
Shh, guys, you're wasting homework time. What's your B? -2. Change the sign for the beginning so you get +2. Plus or minus. Underneath the square root, the way that I teach it is so you don't screw it up, just use a positive, because what happens when you square it anyway? It's going to be positive. So I don't want you to screw it up in your calculator. -4 times A is 3, C is 5, all over 2 times A is 3. You want to just work out the underneath to begin with. If you have to be lazy, that's fine. 2 squared minus 4 times 3 times 5. So I got it. So we get -56. Then we're going to rewrite it, plus or minus the square root of -56 over 2 times 3 is 6. We're going to break down that 56 prime factorize. What are your factors of 56?
7 and something.
7 and 8. 8, remember, is going to be 3 2s. 7 will not break down anymore. Do you see pairs? One pair of 2s. So that means I'm going to pull out 1, 2. What did I leave underneath? And it's going to be a -14 for right now because I have a -56 over 6. How do I fix the -14? Pull out the I. And then your last step is that triangle of numbers. They're all divisible by 2. So 2 divided by 2 is 1. Plus or minus 2 divided by 2 is 1. So I square root 14. 6 divided by 2 is 3. Do not touch the square root part. Okay, do not touch the square root part. All right, so I'm going to show you completing the square just so we can work that as well. So if I had this function right here, ooh, probably shouldn't do it with this one, but we're going to. This is going to be a beast. Okay, just bear with me.
Jeez.
The reason it's going to be a beast is to have to take out 8 from 14. So it's going to be a fraction, but it's okay. So to complete the square, remember we moved this other number over. We'll eventually have a blank there, and we'll go ahead and put our blank over here. Okay. I need to take out an 8. You're doing 14 divided by 8. I'm just going to go ahead and make it a fraction. You don't have to. You can use quadratic. I just want to remind you how to do completing the square and then show you that you can complete the square. If it's an easier one, like if it's 2 and 4, I would complete the square before I do quadratic formula, but you can do whichever one you want to. All right, how do I get this number right here?
Divide by 2, divide by 4.
And then square it. So I get 49.
Oh,
It's not bad. You have a calculator.
this is a beast.
Woo!
You have a calculator. How do you get this over
You
here.
gotta add the 8 back in.
Not add it, but
Multiply.
multiply by 8 and you get 49 over 8. Mm-mm. It's an easy one.
See, bro.
Guys, shush. Remember, square root of the first sign, square root of 49 over 64 is
7,
and then this 49 over 8 minus 9 gives us negative 23 over 8. How do I solve? Get x by itself. Mm-mm. Work on this side because this is where your x is. Move the 8 by dividing by 8. I don't want that. Divide this by 8. We get x plus 7 over 8 squared equals negative 23 over 64.
Attention students, there is a tennis meeting in the commons area at
Now
this
what?
time for boys tennis. Boys tennis is meeting in the commons area.
How do I get rid of
at
the
this
square?
time.
Square root both sides. Guys, shh. That means I get x plus 7/8 equals. This is going to reduce to the square root of negative 23 over 8. Does everybody see that? When I take the square root, how many answers do I have? A plus or minus. Square root of negative 23 over 8. How do I solve for x? Minus your 7/8. Plus or minus the square root of negative 23 over 8. Notice how they have the same denominator, right? Yes. So we can write it together like this one. So our final answer. How do I fix this 23, this negative 23? And then they're both over 8.
Talk about a beast.
Any questions? I mean,
That was like breakfast. I think I'm journey.
In case you're at Food Line and you need to buy some.
all right, there's your homework.
In case someone puts you.
What is?
Every other evening. Come on.